All right, so let's talk about the atomic orbitals. So we originally had the idea that an atom looks like a nucleus in the middle, positively charged nucleus with the electrons orbiting around it. We're going to say we're not going to use that model anymore. It's extremely outdated. We're going to ignore it. It's great for simplistic ideas of how an atom behaves. But now we're going to talk about we're getting more into chemistry, and we're going to talk about more in-depth things. So we're going to now use the more updated model, which is a quantum mechanical model. So Schrödinger, along with Heisenberg, came up with a new idea of what an atom looks like. It's the one we use today. Heisenberg's uncertainty principle states that it's impossible to know precisely both the velocity and locations of an electron at the same time. And he, along with Schrödinger, he kind of like calculated this huge mathematical idea of where an electron can be found, came up with this new idea of what an atom looks like. So if we go over here, we're going to actually try and describe what it is and where an electron can be located within an atom. So if we have a nucleus in the middle, and here is here's the nucleus, and back here is where the electrons are located. There are different energy levels, the principal energy levels where electron can be found. So in the principal energy level, n equals 1, n tells us n is basically which principal energy level is which. We have one orbital. We're going to call it the s orbital. And let's give an idea of what the s orbital actually looks like. If we take this balloon, it's a spherical balloon. S orbitals are spherical in shape. In the middle, we have a nucleus, and surrounding it, we have the idea of where the electron can be found. So there's one orbital for every s in s orbitals. There's only one. Looks like this. So we're going to say 1. In the n equals 2 principal energy level, there is an s also, a little bit bigger sphere. And there's also p orbitals. Okay, p orbitals look slightly different. This is what a p orbital looks like. This is 1. Even though there's 2 balloons, this is 1 p orbital. The nucleus is kind of where the knots are, and electrons can be found either here or here, and it looks like a dumbbell shape. There are actually 3 of these orbitals together, they come together to look like this complicated mess. So electrons can be found in anywhere the balloons are. So the nucleus is obviously in the center, and the electrons can be found here, and there are 3 of them put together to make this 3-dimensional shape. So in the n equals 2, we have 1 s orbital, and then we have 3 p orbitals. In the n equals 3, it also has s orbitals. It also has p orbitals. But it also has a d orbital. D orbitals look like flowers, a little more complicated. I didn't get a chance to make it in balloons because it's a little bit harder. But it looks like a clover. And so the nucleus is found here, and the electron can be found in any 4 of these places. Now, this is just one orbital. This is not 4 orbitals. This is just one orbital. So electron can be found here, 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 or here. So you can find there's 1 s orbital, 3 p orbitals, and 5 d orbitals. They can be oriented in different ways along the axis. The n equals 4 principal energy level. You have an s also. You have a p. Again, you have a d, and then you also have an f orbital. F orbitals are extremely complicated. Each orbital actually looks very different from each other. So I'm not even going to attempt to draw it because each one's a little bit crazy. But there's 1 s orbital. Oops, I'm sorry about that. 3 p orbitals, 5 d orbitals, and as you can guess, there are 7 f orbitals. And f is actually, for now, the highest energy orbital that you're going to find. There are theories that there are other orbitals within the principal energy level. However, we're not going to go there because it's just theoretical at this point. So if you were to put all these guys together, you'd get this insane mess-looking thing. The nucleus being here, the s orbital, the 1 s orbitals, the electron can be found within that, then the 3 p orbitals, then the s, and then so on and so forth. So it's a lot more complicated than the Bohr's model, which is just a nucleus in the middle and the electrons surrounding it. So this is basically the atomic orbitals.